So we have two main ways. One is a DLC coating, which stands for a diamond-like carbon coating, and it's a very hard, tough coating. Our other coating that we use is Cerakote, and that's a ceramic epoxy coating. Cerakote, it's not only offered in a bunch of different colors, which is a big benefit, but it's also wear resistant, corrosion resistant, and very chemically resistant. And it also applies very thin. All these parts are made to function with really tight tolerances. Product will give us basically the colors that they want and the different tools, and then we will go out and get those paints and start testing them to see what kind of issues we might run into. Parts are first blasted with an aluminum oxide blast, and that basically makes the parts rough to help adhesion. The parts are then racked, and the racks basically position the parts so they're sprayed on the same spot. Then the operators will mix the paint and prep the robot. After spraying, the parts will go in an oven to cure, where they basically reach their full hardness and reach their material properties. The operators will then 100% visually inspect each part for cosmetics. They'll also do adhesion checks, scratch test. Then they'll check the color to make sure it matches exactly what we're looking for. They'll go over to assembly to get built in the tools. After assembly, they'll get packaged up and sent out to the world. Coatings not only have to look good, but they also have to perform well. It has to be durable, corrosion resistant, and a lot of times it ends up improving the tool as well. I think initially people are drawn towards the colors that appeal to them, and then once they start using the tool, they realize how useful it is in their everyday life.